Yep, and welcome again to Wider 360. Today we are going to be looking at inverse functions. And before we start, if you remember, we said in one of our previous videos that um, we consider functions to be machines. We consider functions to be machines. So let's imagine you have a machine that when you put in something, it does something to it. For example, let's assume you have this machine. Let me bring the first machine that we used. This machine here. All it does is when you give it an input, let's call this input X. So when you give it an X, it doubles it. Okay, so if you give it a 3, what will you get? 6, because it's going to double it. What if you give it, say, a 5? All it does is double it. So let me just write it here. Doubles 8. So it doubles whatever you give to it. So if you give it a 5, what do you get? A 10. Okay. And if you give it a 15, you get 30. Okay. Now, what if you wanted another machine? We want another machine that will undo what the first machine did. So let's have another machine or another function. And what that function will do is it will take whatever our first machine that doubles it gave out, which is the output. It will take it and then it will manipulate it or do something with that. And then it will give you your original number. So for example, over here, let me just call this our first machine. This is the first machine. That's what it does. And then this is the second machine. So this second machine will take this input, which is the 6. Don't forget the input we said was X. So it will take the 6 and then it will give us our original number, which was 3. And then over here, it will take what X gave out. Let me call that the f of X. It's going to take the f of X. But since it's an input, we are going to call it the X. So it will take 10 and then it will give us what? The original number, which is a 5. So what do you think the second machine does? We said the first one doubles it. So the second one is going to do what? It's either going to halve it or divide it by 2. And it is going to give us an f of X. I hope that's right. So we call this our second machine. The second machine here, we call it the inverse machine. The inverse. So all it does is it reverses whatever our first machine did. So it's just like in real life situations. Let's assume you put on socks and then after that you wear your shoes. The inverse will be what? The inverse is going to be first taking off the shoes and then the socks. Note, you cannot take off the socks first. So the order, O-R-D-E-R, the order matters over here. the other matters here. If there is a message that is encrypted, the inverse will be decrypting that message. If you are locking a door, like you are locking it, the inverse will be what? Unlocking it. I hope that works. Okay, so let's go through some functions here. So we are going to call our first machine, which was doubling it, we are going to call it a function. So let me say it's a function of x. So I'm going to call it f of x. And because it's doubling, we will say it's equal to 2x, or you can call it x plus x. So the first function is going to be f of x. So if, for example, if x is equal to, let's say, okay, let's just use 3, then f of x will be what? Then f of x, looking at this, is going to be 2 times 3, which will give us a 6. Hope that's correct. What about if x is equal to 5? If x is equal to 5, then we are going to have f of x to be equal to 2 times 5, which is going to be 10. Yeah, is it 10? Okay, so we are going to get 10. So over here, the input for the first one was 3, and the output was 6. When you come here, the input was 5, and the output 10. All right. Now let's go to our inverse machine. So we're going to call the other machine the inverse function. So let's call that probably g of x. So for the inverse function, we're going to call it g of x. So that's going to take the output of f of x and give us back the original. I hope that's clear. And we know that, let me call that g of x. We know that g of x, all that it does is divide by 2. We saw it at the top there that it halves whatever we give to it. So g of x here is going to be x divided by 2. Hope that's clear. Okay, let's go on. So we have a special notation for the inverse function. I'm going to write it here. So when we are dealing with inverse functions, instead of saying the inverse or writing g of x to be the inverse function, we are going to write it as, let me write some sentence here. If f of x is a function, then its inverse is inverse, written as f inverse of x. This is how we write it. And here, what you have to note is the inverse function has a -1 at the top of the f. It is not an exponent. It is not an exponent. So because it's not an exponent, you cannot say f inverse of x is equal to 1 out of x. No, it's never equal to that. So take note of it. And this here, f to the power, f, sorry, I said f to the power. F inverse of x, that's how we write it. We read it as f inverse of x, not f to the power negative 1 of x. No. Okay. So let's go back to our functions. So we are going to now call g of x the inverse of f. So I would say g of x is the same as f inverse of x, like that. All right. So if f of 3 was equal to 6, right? Hope f of 3 was equal to 6. Yes. Then what we are saying is, then f inverse of x, which is 6, is going to be 3. And that same way, if f of 5 is equal to 10, then f inverse of 10 is going to give us a 5. All that I want you to note is here. Over here, it was f of x, and then it was equal to y. But when you come here, we take f inverse of the y, the value that we had. It now becomes an x, and it becomes equal to an output, which is a y. At the beginning of our lesson, we said the input is always x, and the output is a y. I hope that's clear now. Okay, so we are going to solve some 1 or 2 questions on how to find the inverse. And then after that, we will call it done. Let me get a question. Before we solve the question, let's see how the solution is done. So how to find the inverse. How to find inverse of a function. Inverse of a function. How to find the inverse of a function. And I'm going to give you some of the steps. The first step is like a recipe. Just follow it and you'll have a very delicious meal. The first step is, as you saw at the top here, as you saw it here, let me bring it down. The first thing that we do is this y, which was a 6, changes to be an x. Look here. The y becomes an x. Control Z, or it went that way. So the first step is going to be replace f of x. F of x with a y. So the first step is this f of x here becomes a y. We do that just to make to make our lives easier. It's easy to work with a y than to be working with f of x. So if you're given a question like f of x is equal to 2x, all we are saying is just make it y is equal to 2x. That's all we are saying for the first step. And for the second step, that's where what I was talking about comes in. The second step is to interchange, or we can say swap x and y. Let me go up here and show you. I know I already did, but I didn't mean to do that. So the next step is to interchange x and y. So interchanging x and y simply means that this output, which was a y, when it comes here, it becomes an input, so it becomes an x. So the 6, which was the output, or which was a y, is now an x over here. So you interchange x and y. That's what we mean. That way your output now becomes your input. So we do that because the inverse swaps the inputs and the outputs. That's all we mean. So for example, if we are using the same thing, then if we are to swap x and y, then it's going to be x is equal to 2y. If we are to use this example here, this one here, then interchanging becomes x is equal to 2y. And the last stage is we solve for y. So we make y the subject. And solving for y, for this our equation, we just say we know 2y is equal to x. So we divide through by 2, we get y is equal to, let me do it well. 2y is equal to x, so we divide through by 2, and we get y is equal to x out of 2. And this y that we just got is the inverse, right? So we say f inverse of x is now equal to x out of 2. This point is very crucial, so make sure you write or you state the last function. And that's it. We found the inverse of a function. And after everything, if you want to verify, you can verify that. You can verify that. So let's take an example. Just one example. After that example, I will end the lesson. But before ending the lesson, I will just give you some key takeaways. Imagine we have a function. So it's going to be a question. So find the inverse of f of x, which is equal to 3x minus 5. 3x minus 5. To solve this question, we go with the 3 steps that I gave you. What was the first step? We said let f of x be equal to y. So we're going to have y is equal to 3x minus 5. 3x minus 5. And the second stage, we said we interchange x and y. So interchange x and y, or you swap x and y. That gives x is equal to 3y minus 5. And then the last stage said we had to solve for y. That's the third stage. So we're going to solve for y. That gives us we have x is equal to 3y minus 5. We add 5 to both sides. We get x plus 5 is equal to 3y minus 5 plus 5. And that gives us x plus 5 is equal to 3y. And then we divide through by 3. So x plus 5 is equal to 3y. We divide through by 3. And then we get the value of y. We get y to be equal to x plus 5, all this divided by 3. And finally, we say that f inverse of x is equal to x plus 5, all this divided by 3. And that will be our inverse function. I would like to add some things here on the inverse of functions. Whenever you are solving for inverse functions, take note, the main idea is swapping the input and the output so that the x becomes the y and the y becomes the x. That's the main idea. That's the main idea. For example, if a function f takes an input a function f, I'm going to write it here. If a function f takes an input a and produces an output b, then its inverse function, f inverse of x, must take b as the input and produce a as the output. So the output here becomes the input. So y becomes x. That's a core idea. Y becomes an x. The output becomes the input. And visually, when you are using ordered pairs, then we will say if the point A, B is on the graph of f of x, then the point B, A must be on the graph of f inverse of x. This is on f of x. So this BA should be on f inverse of x.